The ls command is one of the fundamental commands in the Linux environment, allowing you to list all the files and directories in your current location. It's simple, yet incredibly powerful, especially when you start playing around with the flags. Say you want a detailed output including permissions of each file. You can achieve this with the L flag, like so. The permissions are read, write, and execute. The permissions are displayed in 3 groups. The first one is the permissions for the owner, the second one the permissions for the group, and the last one is for everyone else. Now let's say you're interested in those hidden files, the ones that start with a dot, like .profile or .bashrc. Your bash configuration. You see them using the A flag. Now obviously you can also combine multiple flags into ls.la. But do you see the dot and the dot files here? They refer to the current and parent directory, but we will look at that in the next section. So make sure to stay tuned and leave a like down below. The cd command stands for change directory, and it allows you to move around the file system. If you type cd followed by a directory name, you'll be transported right into that directory, like this. Now you're in the documents directory, but that's not all. cd can take both relative and absolute paths. If you're in the documents directory and you want to go into a subdirectory, say reports, you can just type cd reports. That's a relative path. And remember the dot and dot from before? The dot stands for the current directory, so you can create a relative path to the reports folder with a dot in front, and it will work the same. This is useful if you want to execute a script inside this directory, otherwise it may not work. The dot stands for the parent directory. If we want to go back to our documents, we can just type in cd ... and we're there. For an absolute path, regardless of your current location, you could type something like cd/home/user/documents. This takes you directly to the documents directory. With pwd, you can show your current path and it will display the absolute path of it. Now that we can list the files and navigate around, we may also want to edit or access those files. First, we must make sure that we can even access the files. Remember the permissions from our ls command? What if we're a user that doesn't have the read permissions on a given file? You'll need to escalate your privileges. The sudo tools allows you to execute a command with root permissions. Just put sudo in front of any command like ls or grep and it will be executed as root user. To demonstrate this, let's use a command called whoami and see who we are. If I run this command, whoami will tell me that I'm my normal user, but if I run it using sudo in front of it, it shows that I am root. The root user is the administrator of a Linux system. While sudo is a powerful tool in our arsenal, it's also a potential weak point to guard against. And this leads me to my next command. You don't want to always use sudo to access files or execute commands. Luckily, we can change the permissions of any file using chmod. As long as we have permissions to change the permissions. Remember the permissions we checked with ls? We can set each of these groups. Chmod offers multiple ways to do so. The simpler way is to use a shorthand notation. We define who gets the permission and what kind of permission they get. We start with chmod and then define who gets the permission. U stands for the user that owns the file, aka the owner. G is for the group and A is for all or everybody else. We follow that up with a plus or minus, depending on if we want to add or remove permissions, and then the permissions. We have X for execute, R for read, and W for write. We can also combine them to give more permissions. And last but not least, we add the file we want to change the permissions to. Another way is a bit more complex, but once you get the hang of it, it's pretty simple. Just imagine the 3 permission blocks as binary numbers. A 1 sets the permission and a 0 removes it. Now all we have to do is define the bits we need for each group and convert them to decimal numbers. I know, not your everyday math, but you'll get the hang of it. And we set the permissions. Now let's turn our attention to the find command. This is a powerful tool that allows us to search and locate files and directories based on specific conditions that we set. You can even combine your conditions with and or not logic operators. But first, you need to define the directory you want to search in. This could be a specific absolute directory, root, or your current directory. In the realm of cybersecurity, find becomes an invaluable tool. For instance, we can use it to find files with specific permissions. This can be particularly useful when trying to locate files with the SUID bit set, which could lead to privilege escalation if misconfigured. Now that we can access and find any file we like, we can use other tools to filter some content. Have you ever tried to find a single sentence in an entire book? Frustrating, isn't it? But that's exactly what grep can do for us. The grep command allows you to search for the specific patterns within files or even output from other commands. Let's say we want to find emails. We can use the following process with regex 101 to determine the correct regular expression. First, we write down some email addresses down here. Then we can move on to the regex. Let's start by understanding what an email address looks like. It usually has three parts. The name part before the @ which can contain alphanumeric characters plus periods, underscores, and hyphens. The @ symbol itself, and the domain part which contains alphanumeric characters, periods, and hyphens. To match this in a regular expression, we might use a pattern like this. This may look complex, but once broken down, it's relatively straightforward. Let me know in the comments if you'd like a video on regex in the future. But when we're dealing with large files such as logs or extensive reports, it's often necessary to focus on the most recent activity. This is where the tail command comes into play. It's a simple yet powerful tool that outputs the last part of files, allowing you to keep an eye on the most recent data. Without flags, it will just display the last 10 lines of the file. This can be useful, for example, if you compromise the server of a web application and want to see how different actions get logged in the server. Just perform the action on the website and then tail the log. But this could become a hassle, especially if you have to do it over and over and over and over again. This is where the F flag comes in handy. With the F flag, tail keeps the file open and appends data to the output as the file grows. This is real-time monitoring in action. Tail can also be configured to show more or less data. For example, the last 4 lines. You can even use it on multiple files at once, even with the F flag, giving you a live monitoring system for all the logs you want. If you don't like the interval in which the output gets updated with F, you can set a slip interval in seconds using the S flag. Now that we can navigate around our local system, it's time to move on to the network side of things. If you want to check what kind of services and applications are running on specific ports, you can use the command netstat. To get a list of all the active connections, you can use the netstat A command. Similar to the tail command, it will keep your terminal busy and show you new active connections live. But let's say you want to see which applications are using which ports on your system. The netstat P command is perfect for that. Tools like netstat give you a window into these protocols at work, allowing you to understand the communication landscape of your system or any system you're investigating. If you're dealing with remote servers for your websites or digital platforms, or happen to find credentials for your target, SSH or Secure Shell is an extremely important command. So let's see how it works. If you want to log into a remote system, the syntax is quite straightforward. Once you run this command, you'll be asked to enter your password for the remote system. After you entered your password, voila! You're in. The secure part in the Secure Shell comes from the fact that SSH uses encryption to secure the connection. So even if someone intercepts your traffic, they can't make heads or tails of it. You can even add an additional layer of security by using SSH keys for authentication instead of relying on passwords. SSH keys are nearly impossible to crack using brute force methods, making them a safe choice for anyone operating in high-risk digital environments. SSH isn't just for logging into remote systems, you can also use it for tunneling, which allows you to redirect your traffic in a way that's secure and hard to track. This can be especially useful when you're working in environments with strict network restrictions. The last tool on the list is wget or curl. These commands allow you to interact with the internet directly from your console. The wget command is a non-interactive download manager. It downloads files from servers using protocols like HTTP, HTTPS and FTP. Here's a simple example. wget followed by the URL and the location of the file you want to download. This command will download the file named file.txt from example.com to your current directory. Curl, on the other hand, is more than just a download manager. You can also use curl to check security headers, test APIs, send data, and much more. In a cybersecurity context, these commands can be used for things like downloading scripts or other resources during a penetration tests, or even downloading a web page's HTML for analysis. To practice all these commands, I would suggest you join Hack the Box and practice the commands on some Linux machines. You can filter the machines based on the OS they're using and just select Linux. Some of the machines may require a pro subscription, which you can get with my affiliate link in the description, but there should be at least 3 free retired machines.